Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day to my panel and my supervisor. My name is Muhammad SYAZWAN ROSLAN from 4BEZ section 1/1. Today, I would like to present my BDP 2, which is titled Development of Q-switch fiber laser using tantalum aluminium carbide thin film as suitable absorber. Introduction. Fiber laser or optical laser can be doped in the rare elements such as neodymium, iridium, and holmium as active medium. It also can be used in Q-switch to produce pulse in kHz and MHz. Q-switching method can generate high pulse energy relative with low repetition rate in kHz and longer width pulse in microsecond. Q-switching consists two parts: active, will losses modulated with an active control such as acoustical or electro-optic. Passive, will losses modulated by the suitable absorber. Tantalum aluminium carbide as the material used. So, tantalum is an atomic number 73 in chemical element. Aluminium, an atomic number 13 in chemical element. Tantalum aluminium carbide is MXene family. Problem statement. Different length of EDF effect lasing characteristic. So, when we use EDF I25, the length to get the optimum or height of amplified spontaneous emission ASE, we will use 2.5 meter. Height cost of material normally used for SA. Normally, in Q-switch experiment, we will use graphene or carbon nanotube, which is the material is quite expensive. Different suitable absorber will affect the effectiveness of laser operation. So, not all the suitable absorber will use range of 1.55 micrometer. Objective: to study the lasing characteristic of erbium dot fiber, to investigate the characteristic of tantalum aluminium carbide as suitable absorber, to demonstrate a Q-switch EDF lasing using tantalum aluminium carbide thin film as suitable absorber in 1.55 micrometer region. Project features. About the material, we will identify a new formula or fabrication process to create a new suitable absorber. For example, we can add on the amount of powder used or the value liquid to be used. About the setup experiment, increase the frequency in laser operation by generate high input pump power. So, when we contribute a high power pump power, it will produce high output power of pulse laser to get a stability waveform. About the stability, develop a thinnest film of suitable absorber that can produce high power which is not easily damaged. Even we apply the high input power laser source flow through this circuit. We move to methodology. For the flowchart, start with literature review, fabrication of tantalum aluminium carbide as suitable absorber, which is the process to create the SA, application of pulse fiber laser, erbium dot fiber laser. We'll go to data analysis and the result. So the material process. For the first one, PVA setup. PVA setup, we mix up 1 gram PVA powder and 120 milliliter of RO or dinosed water. Ultrasonic process. For the cleaning process, centrifugal process method of separating molecules having different density by spinning of distributable machine at high speed. Heating process. To dry the raw material of the powder. Dilution process. Decrease concentration of solute in this solution. Dry process. To dry the liquid from the dilution process to get a thin film. So about the experimental circuit of the setup. At first, laser diode pump 980 nanometer will pump an optic laser through the WDM, which is wavelength division multiplexer. WDM is used to multiplexing some optical carrier signal, and then we through the EDF continue to gain at the gain medium EDF with 2.4 meter through the isolator. So isolator is to enable unidirectional operation in the cavity, and then through the fiber connector, which is the cerebral absorber is implanted in this fiber connector to produce a Q switch pulse or Q switch waveform through the optical coupler and go out to the oscilloscope output. For the result analysis, for the first one, optical spectrum analyzer OSA, at the pump at the minimum pump power 71.53 milliwatt will consist Q switch 1561.40 nanometer. For the RF spectrum, radio frequency spectrum, so we can see the SNR is about the 30.1 dB. So for the repetition rate pulse of fiber with tantalum, aluminum, carbon, etc. against input power. So when the pump power is increased, the repetition rate increased too, but the pulse width decrease along the increase of pump power. Output and pulse energy will increase together when the pump power increase too. Pulse trend for the minimum level as shown as this result. So this one, when the pump power at the minimum pump power, middle of pump power, and the maximum of pump power. So the project potential of commercialization for this project focus to medical industry. Example, LASIK surgery. The operation of eyes and aesthetic removal tattoo to remove the tattoo by using the laser. So the inventiveness, reliable span of material. So that means the material that I use can have a lifespan longer. Depends on environment of the material. Ownership cost, which is the reasonable price to produce the project. Friendly design of project, which is have a compact size of circuit setup and production process of fiber laser. So from this experiment, I gained a new knowledge, the process or the method to use and to produce a fiber laser with a certain formula to produce an experiment. So the conclusion for this project is, this research successfully show Q-switch fiber laser that produce short pulse in 1.55 micron range. The cerebral absorber in this study was manufactured using a rare element material with tantalum aluminum carbide. When the pump power was increased, the frequency will rise too, while the pulse width will decrease. So that's all from me. Thank you for having my time. and Assalamualaikum warahmatullahi wabarakatuh.
So this one is dilution process. Here is I'm doing the process of oscillation pulse train. So we need to setting the oscillator and jot down the pump power frequency pulse width according the result we are get. And then we need to save the image. After that, we move to the pump diode and increase the pump power to get the next pulse train, and repeat again the process and jot down the result. So there is a few demonstration of my project, and thank you.